I've always wanted a proper RC off-road vehicle, and as great as my WL Toys 124019 is, it is not a proper off-road vehicle. Don't get me wrong, it's a fantastic road vehicle, but when grass is your biggest enemy as an off-road vehicle, you suck as an off-road vehicle. The search continued until I remembered a toy I've always wanted from my childhood, the Tyco Terrain Twister. The Terrain Twister is propelled by a pair of horizontally rotating screws instead of tank threads or wheels, and these screws make it possible to traverse sand, grass, mud, snow, carpet, and even water. The Terrain Twister can also strafe laterally on every surface except for water. Just as I was looking for the Terrain Twister on eBay, I came across two videos about upgrading the Terrain Twister with hobby parts. I purchased mine with the intention of doing the same. Instead of using two ESCs and having to program and modify my stick radio for skid steer, one of my reference videos pointed me to a dual motor ESC. This ESC takes your throttle and steering inputs and mix them to give you one dual motor output. For this project, the parts I acquired was the Terrain Twister from eBay, a cheap surface receiver, the dual motor ESC, JST pigtails, and a pair of 1000 mAh 2-cell lipo batteries with JST connectors. The parts I already had was a soldering iron, a screwdriver set, and a stick transmitter. I opened the Terrain Twister and clipped the wire to the antenna and clipped the wires to the capsule in the brain of the twister. Two JST pigtails were soldered to the daughter board, which holds the motor connection. The orange and blue wires on the left and the green and yellow wires on the right went to the black pod, which holds the electronics. I could have attached the pigtails to these wires, but I decided against it. On the daughter board, you can see from right to left M2 positive, M2 negative, M1 positive, and M2 negative. The red wires were soldered to the pluses and the black wires to the minuses. When plugging in the ESC to the pigtails, the M2 pigtail on the daughter board plug into the M2 pigtails on the ESC. Same for the M1. The green and brown wires connect to the brush motor that controls the tilt mechanism. This mechanism allows a vehicle to tilt forward and backwards, and this is useful for creating arcs when strafing laterally. I really want this functionality because I do strafe, and while I'm strafing, the vehicle does create arcs, which it shouldn't because the pontoons are level. They're not tilted forward or backwards. But I don't know how to make the brushed motor work as a 3-position servo. So if you guys have any idea how to do that, please let me know in the comments down below. Now, after binding my receiver to my transmitter, plugging up the throttle and steering into the receiver, and giving the entire project power with the lipo batteries, it works pretty well. In this demonstration, I have the steering both forward, backward, and left to right mixes on the right stick. Here is a quick demonstration of the Terrain Twister on carpet. This controllability works on all surfaces the screws can dig into. I was having some issues tracking straight when giving the Terrain Twister pure forward input. I believe this was because I was giving lateral inputs, since the forward and steering control is all done on one stick. I'm gonna change that. On water, the Terrain Twister, well, it's a bit faster than I expected, but it is super smooth. You track straight, turn right, turn left, and forward. It's all good. But instead of strafing laterally when you give it full right or full left with no throttle input, it spins on a dime. I guess this is the screws spinning instead of rolling on the surface of the water. I would like the tilt function to shift the center of gravity instead of having the Terrain Twister sit back like that. I would like it to sit forward to see how that affects performance. Getting out of the water, very difficult. Alright, and here is an outdoor in grass demonstration of the Terrain Twister. As you can see from the picture in the top left, I have moved the forward and backwards controls on the right stick, which self-centers, and my strafe left right is on the left stick. This clip here demonstrates crossing on pavement not using the strafe function. It can go forward, but I wouldn't recommend it. You would grind down the screws. Alright, I'm giving it just pure forward input, and the right motor, which is M2, was not responding. Same as I thought on the carpet. I thought that I was giving it a little bit of lateral input because I was using one stick to move both at the same time. Look, you see? The right one's not moving. I'm giving it pure forward input. Look at this. Alright, so I thought this was a mistake with me and my soldering the pigtails onto the connectors. So I just did that. Same day as the recording. Today is the 21st of June. Resoldered it. Same thing. I'm not sure if it's the ESC that is faulty or if the motor itself in M2 or the right pontoon is having issues. As you can see in reverse, the Terrain Twister responds exactly how you expect it to respond. It takes commands better in reverse than going forward. Alright, this clip I am strafing. Well, ignore this part here when I'm going over uneven terrain. But here, when I'm strafing, the Terrain Twister is arcing, which it should not because the pontoons are, well, they are parallel. Alright guys, that's it for this project, upgrading the Terrain Twister to hobby grade parts. If you plan on doing this project yourself, I must say, it only took me about 20 minutes to do everything because, and only because, I was filming it. But it should take about 5 minutes maximum, 5-10 minutes, if you plan on doing this yourself. And I must say, this project here is a lot easier than the time I decided to put LED lights on my airplane. If you guys know how to use the tilt motor as a 3-position servo, feel free to let me know in the comments below. That's the only thing that's kind of bugging me about this project, apart from M2 working whenever it feels like working. If you want a more technical explanation of how to do this project and you don't feel comfortable watching my video as a guide to completing your own project, feel free to check out reference video number 1. I'm going to put a star next to it so you can check out that one, and that is the guide I used when completing my project here. Alright guys, thanks for watching, see you on the go round.